All right, good afternoon, everybody. Welcome to the Frontiers in Brain Health, where we take a wide-angle lens on many topics that affect how we measure the brain, how we intervene to improve the brain, and of course, measure things like brain health and brain performance. So I think today's talk is a representative of that approach, taking a wide-angle lens with many academics who deal with a variety of approaches and a variety of data. So I will welcome the online audience. This is being broadcast, so if you have questions and you're in the online audience, go ahead and add them in the Q&A, and we will usually get to some of those, as well as, of course, in-person questions. I'm going to turn us over to our host, Dr. Richard Golden, who is going to introduce our speaker.
Thank you. It's my pleasure to introduce a colleague and friend of mine, Dr. Russell Almond. Dr. Almond received his undergraduate degree from Caltech, and then his PhD from Harvard University in statistics. And then he was a member of the elite research group at Educational Testing Systems for approximately 14 years. And now, currently, he is Associate Professor of Measurement and Statistics in the Department of Educational Psychology and Learning Systems at Florida State University. He's a co-author of a book which I just love called Bayesian Networks in Educational Assessment, and I encourage you to check that one out. In any case, here is Dr. Almond.
So you might notice on my thing, we're now the Ann Spencer Davis College of Education, Health, and Human Sciences. So first, we've got ourselves a big donor, which is always exciting. But the second thing that's kind of interesting is I've been at Educational Testing Service and in the College of Education for a long time, but the College of Education has merged with Health and Human Sciences. And I think that the problems of measurement are actually common between education and human sciences. So a lot of what we've discussed in education, in particular, the constructs that we want to measure are invisible. So I'm borrowing this analogy from this lovely book by Lawrence and Karen Kushner. It's a children's book, which is very, very nice, but it starts with the idea that we can't see the wind, but we can see what it does. And now what we need to do so we see evidence of the fact that it's windy. So now what we need to do is turn those ways of gathering evidence into a way of measuring it, right? We can now build an anemometer so we can actually measure the wind even though it's invisible. Generally in the human sciences, I think what we do is we take observations of our subjects, right? We put the person comes into the doctor's office, we ask them to do something, the student comes into the classroom, we give them a worksheet, right? And we observe what they do, right? So the example here, the James Goodfellow is applying to graduate school, and the sample paper was well written, right? So that's an observation in the past. What we want to know is what is likely to happen in the future, and that I would call that a claim. So what we want to say is, hey, if James Goodfellow can write good papers, then maybe they'll be a good student. So claims often come in bundles that indicate some kind of state of the subject. And what we tend to call a construct in educational psychology is sort of something where up at the high end of this construct, we expect to see sort of positive results when the person attempts to do something. And down at the low end, we expect to see negative results. Now, what I mean here by positive and negative can be a little bit funky because, I don't think about having more depression or more anxiety as being particularly positive, right? But there's certain signs that you'd expect to see in a person who is depressed or anxious, but you wouldn't expect to see those signs in a person who was functioning more normally. So usually in the human sciences, a lot of what we're interested in is tasks. So the person attempting to do something and being either successful or not. So solve a math problem, write a paragraph on a topic, or the sort of educational things, remember a set of words. I was just recently in physical therapy for some problems with my neck, right? So the question is, when I turn my neck like that, do I get pain, right? Or participate in everyday activities when we're thinking about seniors and can they live, or even a person suffering from profound depression, is it interfering what they do? So, in the science of measurement, we're going to call this a transduction, right? We're going to use this task to somehow produce a visible result from some kind of invisible process that we're hypothesizing is going on. There's two special kinds of tasks that need some additional thought, although I'm not going to get a whole lot of time to go into him here. One of them is reflection. So when we ask a person, how much pain are you in today? Or does the thought of giving a talk make you nervous? And ask them to rate that on a Likert scale. So one of the problems we have here is there's going to be considerable greater variability. There's some people who are going to be very pain tolerant, and we'll say, and there's some people, they want a medicine at the least a little bit of pain. But however, differences have less bias, right? So, okay, so my pain rating, my initial pain rating may be subject to whatever my pain tolerance is, but the one I'm giving you a week later and so forth is probably okay. The other thing that often we ask subjects to do is recollection. So, how many days in the last week did you feel sad? And we all know that there's lots of biases in memory. So these tools are very important, particularly because they're generally pretty inexpensive to administer, right? We don't have to pay human scorers or train some bizarre machine learning thing to do that. But they are also subject to these biases. So I'm going to be drawing a lot on the work of Mark Wilson, but I went to a conference this summer for the Society for the Study of Measurement, and was pleased to go to a workshop given by Luca Marie and Mark Wilson about this measurement across the sciences. I can highly recommend this book, not the least because it's available online for free. But it's a very much a philosophy text and not sort of technical. So they have this hexagon model of measurement. The example they were using was a historical measurement, but being here that we're talking a little bit more human sciences, I'm thinking now measurement by sticking a thermometer under somebody's tongue, right? So what we're interested in is the temperature of the subject. And so we stick the thermometer in there, the mercury goes up in the tube, so now we can transduce this temperature, which is not something we can see, to this height of mercury, which we can see. And so then we do some matching, so we're going to read the thermometer. We're going to say, okay, which mark is this closest to? And then there'll be some sort of internal scale so that there's some numbers on the tube, and we can say, oh, this is what the patient's temperature is. Meanwhile, so that's going up around the top end of the loop. Going down around the bottom end of the loop, what we have is some reference temperatures, right? So we've looked at the temperature of a large number of healthy individuals, and somebody, maybe it's the CDC, has developed a sort of a public scale. They've said, this is the normal range, and if you're higher than this temperature, then that's a problem, and if you're lower than a temperature, that's a problem, right? So the last sort of bit there, this calibration link, is going from that local scale, however many millimeters the mercury has moved in the tube, to this public scale, which is, degrees Fahrenheit or degrees Celsius, right? And so there's some sort of calibration process, and probably the manufacturer of the thermometer has done some sort of testing to figure out exactly where those marks need to be, so that this internal scale, which is going over the top of the hexagon, and this external scale, or public scale, which is going around the bottom of the hexagon, are in alignment. I think this is a sort of a wonderful idea for how to do these kinds of things. So here's another example, right? So I've got a bunch of school kids, and I hand them a math worksheet, and I ask them to do it, right? So the transduction step now is the answers that the students write down to the problems, and I've doubled the box there because there's going to be multiple responses. And then we have to do some sort of scoring, right? So somebody, the teacher or somebody else, is going to mark them correct or incorrect or partial credit, right? And so then we have this collection of marks. Then we have another step where we're adding them all up, right? So maybe we're just taking the sum, or maybe we're got some kind of weighted sum with some problems worth more than others, and we'll get a score. And now down around the bottom of the list here, we've got some sort of mathematical standard. So what kind of math problems do we think a fourth grader ought to be able to do? And that's going to come together with a public scale. So the question then is, how do we calibrate our local scale, the classroom scale for this particular worksheet, to this global statewide scale for what we expect fourth graders to do? Here's another educational example, writing an essay. So we're interested in the language ability. We ask them to write the essay. We get the essay. Then we have some sort of scoring rubric that the person is looking at, or maybe we have one of these automatic scoring algorithms like E-Rater or Telerator or whatever Duolingo is calling whatever new things that they're doing. And that's looking at certain different features of that essay, like how many misspelled words there were, and how many paragraphs, and whether each paragraph had a single topic, all those kinds of things. And those somehow are turned into points in some sort of scale and accumulated together to give a score. And meanwhile, down along the bottom, we have the expectations for what a person at this particular stage of their educational career would be expected to do, so we can sort of say, oh, this is a person who is writing, able to do the kinds of writing tasks that we'd expect of a high school graduate, and this person is still struggling to do those things. So, as I've been working in various sort of computer and game-based education systems, it's occurred to me that there's sort of 4 generic processes that happen in any educational system. And I tend to think about what I'm doing in terms of these processes, although in many cases, the process may be buried somewhere else in what they're doing. So the first thing is that somebody has to figure out some way of picking what tasks the subject is going to be asked to do, right? So we might have a fixed form with the problems, and you just go through the first one to the last one, or we might have some sort of adaptive system where after we see the first one, we pick another one from a pool of problems. But there has to be some sort of procedure for saying, okay, this is the next problem, this is the next problem, okay, we're done. Then there's got to be a system that's going to present the problem to the subject, have the person attempt to solve the problem, and capture details about both their solution and the process they might have used to get to the solution. So one of the key questions here is going to be, as we're thinking through this process, what exactly do we want to look at, right? So my physical therapist is looking at me turn my head one way, turn it the other way, and then seeing sort of how much I grimace and what the range of motion is, and asks me, right? So she's doing the activity selection, and sort of based on her mental model of what my problem might be, she's suggesting other new tasks that might help. But she has to be looking at me to figure out what she wants to capture. Very often, there's another step now, which I'm going to call evidence identification, that we're going to have to take the raw data here and get it into something more manageable, right? So we have to score the math problems, or grade the essay, or if we've got a bunch of eye tracking data, we have to convert that into how much time did they fixate on the problem versus how much time were they fixating someplace else, right? So there's this first sort of evidence identification steps, which the goal there is to capture what I'm calling the observations, the observables. And then there's an evidence accumulation that says, how are we going to do this across all of the tasks? So this actually maps nicely onto the hexagon, right? The first arrow going up there, now all the arrows are doubled, is the evidence capture, right? So that's the part where we're having the person do the task and we're capturing the raw evidence. The second step, what they were calling matching there, that's the evidence identification. We're looking for features in that raw response that are somehow useful and helping us determine what's going on. We're going to map those onto one or more scales. And down along the bottom, what we're going to have is our claims. So now we have sort of what we want to do, right? So my physical therapist is saying, okay, what I want to do is figure out what the right exercise is to make my patient here pain-free. So is this data that I'm getting from this process, is it helping me classify that person into exactly what exercise should I assign to them, right? For a teacher, right, it's okay, has the class mastered this particular topic and we can move on, or are they still struggling with it and do we need to do some review? So I know the word assessment has a slightly different meaning in the educational and the medical context. So what I'm going to call an assessment is a plan, either executed or not, right? So after we've executed the assessment, we have the results, but before we just have a plan for how to make some set of observations that we want to make about our subject. So we have our task or activity selection rules. So how are the tasks going to be chosen? What's the possible list of tasks we're going to do? We have evidence capture rules that tell us what details of the outcome and the process that the person is undergoing are we going to try and capture. Evidence identification rules, which are going to look at sort of scoring within a single task, and evidence accumulation rules, which are going to talk about how the composite score can be calculated from the observations. There's two other things that we also have to sort of consider here. One is eligibility. Who is this for? Right? So a test for fourth graders and a test for 10th graders is pretty different. And as would be a prescription the physical therapist gives to an athlete in training versus one that they give to a senior citizen, right? And then environment, what resources are available and so forth, right? Are the students allowed to use calculators or not? Is it going to be in a climate-controlled room, or is it going to be outside in the freezing cold or blazing sun, right? And all of those sorts of things are part of this general plan because they're going to impact on the evidence we're collecting. And so the other thing that I think we've gotten out of the measurement hexagon here, which I think is very helpful, is the idea of an internal scale, or either a local scale or an operational scale, right? So these are the observations. This is how we're making the measurement. And from that, we can get at internal consistency, right? Is this collection of observations really measuring the same thing, or are some of them measuring something that's a distraction from what we want to measure, construct irrelevant variance, as it's often called. And then we have the external scale, which is the public, the theoretical, the public scale or a theoretical scale, right? It usually corresponds to our theory of what's happening, and it's related to these claims. And the central question of validity is, do the internal and external scales refer to the same construct? So the example I sometimes give my students is, if I have, on my statistics test, I have a construct that understands how to get information from tables and graphs, and I give the students a bunch of graphs to look at, but never give them any tables. There's now a mismatch between my internal scale and my external scale, and that's a potential problem, and somebody could misinterpret it. Now, there's practical constraints here, right? So, in my claim, right, I wanted to figure out whether or not my applicant to my graduate program can write a paper, because they're going to have to do a lot of that. But on the GRE writing exam, they're asked to write a 3-paragraph essay in a half an hour, right? Because the GRE can't give them the amount of time that it would take to write a full research paper. So there's the sort of inherent mismatch here, and I have to then make the argument that what I'm doing here is, is good enough for what I can give, right? So other things here, we only want to do a expensive or risky assessment if there's a good value of information. So taking a patient's blood is pretty safe and relatively cheap, whereas an MRI is relatively expensive and a biopsy is considerably risky to the patient. And often, thinking about a test that might not be practical might inspire something that is practical. So if I said, oh, gee, I'd really like to see this person on a treadmill, that you might be able to easily ask, do you tire easily when exercising, and get much of the same information. One thing I will say about these sort of tasks that don't meet the practical restraints is that they're good to revisit when we're coming to do validity studies. So we might not be able to do them with every single subject in our study, but we might be able to do them for a small subset. So the heart of what we're doing here, right, when we're defining a measure, is we're thinking about the relationship between the observations that we're making and the claims that we want to do, right? So when I observed that James's sample essay was good, does that support the claim that James can write good papers in the future? And so we can think about warrants, right? Okay, this might be, because this sample paper is similar to the kinds of things that we want to do. We might want to think about alternatives. Boy, James might have had a lot of help, or he might have used ChatGPT to, right? So we need to sort of think through this evidentiary argument. The Tolman diagrams, Stephen Tolman was a legal scholar. They were originally designed to help lawyers think through the arguments they wanted to make in presenting evidence, but they work very nicely here. So I think I'm going to skip over this one here and go to the example, right? So the claim is the job candidate, we're hiring somebody for a secretarial type position, and they're going to have to produce relevant routine business correspondence. The observation is that the candidate's cover letter was well written. The warrant is the cover letter is a kind of business correspondence, so maybe that's good, and the alternative is the candidate might have had help. Right, so what we want to do is engineer situations so that we're increasing that warrant and decreasing the alternative. So one of the things we're going to have to do is think about the situations in which we're making the observations. So a situation is that we have a particular subject who's working on a particular task in a particular environment. And so we have details about each of those sorts of things. And a context is going to be some sort of set of situations, right? So the situation, each of you are sitting in an individual chair, but in the context, you're all sitting in this room, right? And so for what we're doing, that might be sufficient. So variables can be unknown, and contexts are nested within others, right? So you're sitting in this room, and you're sitting in this building, and you're sitting in the city, and so forth and so on. So a task is some sort of sequence of actions that the subject performs in pursuit of the goal. We've got some sort of prompt, which is instructions to the student, which might include implicit things. It also might include, or explicit things that are written down. It also might include implicit things that the student is expected to know, right? You're expected to know that you're not supposed to be obviously looking at your neighbor's paper. It might not be actually written down. We have a rubric, which is a set of instructions for a particular task. We have a scoring rubric, which might or might not be shown to the student about how it's going to be graded. And often it's going to have a particular topic area, right? So we might say, oh, this is about the natural sciences, or this is about the social sciences. And then there's various resources. So there might be content like a essay to read, or a web page to look at, tools like a calculator or a spell checker. You might or might not be collaborating with other people. And you also have the subject's experiences and memory, which they can tap in. A work product is sort of what is produced. So it's the outcome of the task. It could be a selection in a multiple choice. It could be a document. It could be a drawing. It could be the state of a simulator at the end of a simulation. Work process is the series of steps that they took to get there, like a log file or an audio or video transcript or something like that. So an observation is that there's some detail, some particular property that either a work product or process has, right? So the answer was what we consider correct, or all the words in the essay were spelled correctly, or the patient was able to make that particular motion without pain. And so an observable is sort of an opportunity to make that particular thing, right? So we ask the patient to make that particular movement, and then we look and see whether there was no pain, or the mild pain, or severe pain, right? Environmental features are important, right? There might be distractions like noise, or the air conditioning's broken down, or the power goes out on the computer and nothing works. There's security, right? Whether or not there's a high enough stakes, so you're proctoring to make sure that the student is working on their own or not. Tool availability, things like that. These tend to be the things that are across many tasks in the assessment. And then there's personal features that they'll bring in, right? So the mobility of the patient, right? Especially if you're working with patients who have been injured. Visual and audio acuity, right? If you're working with students who have limited vision or limited hearing. What kind of preparation they've been done, right? So you might tell the people that the quiz on Friday is going to be about Hamlet, so you better read Hamlet. Or you might tell the person when you get your blood reading next week, you should fast for 12 hours before you do that. And then there might be aversions, right? You might have sort of cultural norms or taboos or personal experience, right? So if your pet just recently died and the teacher asks you to read Old Yeller, you might not be particularly, you might have some distraction from doing the task. And then there's sort of interactions between these things, right? So if the person is familiar with the task that you're doing versus unfamiliar, you're going to get a different kind of response. A person who has ADHD might struggle more in a noisy environment than a neurotypical person. If the calculator, whether or not there's a calculator available doesn't really matter if the problem doesn't require any calculation, right? So those interesting things about these interaction features is they support some personalization. So one of the goals when we're thinking about this, or I think one of the reasons why this is all useful, is we want to think about engineering the tasks we're using in our assessment to improve the evidence, right? So we're going to constrain the environment to eliminate sources of variability that are irrelevant to the construct of interest. We're going to ensure the subject eligibility rules and the subject preparation rules that this is the right kind of person for this particular test, right? We don't want to be doing some weird test for some rare disease that we have no idea, no reason to think that person has. Want to increase, as much as we can, we want to sort of increase the warrant, move features that are going to increase that relationship between the observations of the claims and decrease alternatives, other reasons why we might see that observation even in the absence of the claim. So, so we have an observation, which is something that they did, and a claim, which is a prediction about a future observation. And one of the things that we find is that claims sort of cluster together, right? So we think about writing. Okay, so one of the factors about writing is whether or not you have commands of mechanics, and mechanics include spelling and punctuation, right? And so you can see how there's a sort of a natural hierarchy, and so now we can sort of think about this kind of, okay, we have a whole bunch of claims here that are related to writing, so maybe we have a kind of an illusory, an imaginary variable we're going to call a construct, right? So these constructs are all theoretical, right? They're things that we have come up with because it explains a bunch of things, right? The person is a good writer, and therefore we see a number of different things in the thing. The person is depressed, and therefore we see a number of different behaviors that we see in depressed people that we don't tend to see in non-depressed people. So the idea is that this construct, we got this sort of variable here, and at various levels of that construct, it's going to support different kinds of claims. And then down at the bottom, if we think the person is at different points in that construct, we think that we're likely to make certain kinds of observations or not. So we're going to sort of put this in the middle of our thing. So one thing, the construct is an ordered variable. And for the levels of the construct to be identifiable, there has to be a difference of at least one claim, right? So it doesn't make sense to have sort of high and high if there's, on this particular construct, if there's not something that we expect high people to do that sort of high people can't do, right? There's just no reason to keep it there. And then we're going to take a look at an idea called a construct map, and this really comes from Mark Wilson's book, Constructing Measures. But the thing that I think is a little bit different here is I'm going to talk about two different kinds of construct maps. We're going to have the internal construct map, which is going to place our observations along this scale, and the external construct map, which is going to place the claims along the scale. So a little bit here about the context, right? So we're gathering these tasks. So we're making our observations in a specific context. We're trying to, right? We're controlling the environment. We're controlling the details of the task, and we're making the claims about particular kinds of contexts. So, and those contexts are going to control the warrant and alternatives, which is going to control the sort of the amount of evidence that can flow through those arrows. So, this is an example that I've taken from Mark Wilson's book on constructing measures. It's a physical functioning scale. Mark doesn't say, but I imagine that this is the kind of thing that might be given to seniors to try and evaluate whether or not they can live independently, or they needed some sort of assisted living. So up at the top, we have some sorts of things that we think an active senior can do. In the middle, we have things that we think a sedentary senior can do, but they probably can't do those things up at the top that the active seniors can do. Down at the bottom, we have people who have limited mobility and might need some assistance. So when we're manipulating the features, there's two different ways we can think of trying to construct the scales. And the first one I call the high jump method, because what we're going to do is we're going to keep raising the bar until the person can't jump over it. All right? So we're going to make the task more and more difficult. So if we had a vocabulary thing, right? So down at the lowest level, they can't do anything. At the next level up, they can define some common words. And at the moderate levels, they can define some uncommon words, and up at the, somebody who has a really large vocabulary can define obscure words. So what we're doing is we're sort of moving the difficulty of this up. So the long jump, in contrast, right, the task is sort of the same, but you're measuring how far the person gets. So, what qualities do you see in the response? So the prompt here might be, how many synonyms can you produce for this word? So somebody with a weak vocabulary will only produce a few, with moderate vocabulary more, and a large vocabulary lots. Right? So the difference, so what we're seeing here is a difference in the performance rather than a difference in the difficulty of the task. Now, of course, you can manipulate both, and sort of the goal here is to do those tasks. Okay, so they're asking me to speed up a little bit. So I'll talk a little bit here about weight of evidence, but not a whole lot. The weight of evidence here is the thing about that equation, right, is that I have the probability of seeing this, making this observation when my hypothesis or claim holds on the top, and the probability of seeing it when it doesn't hold on the bottom. And so the bigger the gap is between those two, the bigger that ratio, the more evidence we have for the hypothesis. So if changing the feature, if we change a particular feature of a task or the environment or the subject, and it doesn't change its weight of evidence, then that's called incidental. And if it does, it's called radical. So this is from Sid Irvine. And a lot of this comes from automatic item generation. Incidentals are interesting because it allows us to automatically make variants of the task, right? We can change the names of the people in the story, and that's not gonna change what's going on. But if we change the amount of really long and difficult words in the story, then that might actually change something. One thing that we can manipulate our features for is we can use them to manipulate the demand of the task. So how much of the construct do you need before you can do this task? It's sometimes called difficulty, but difficulty is a little bit, it's a strange word because the psychometric definition and the lay definition are at odds, right? I can make the question very, very difficult by putting it in a very tiny font and forgetting my glasses. But that's not, what we want is we want difficulty that's related to the construct. So people who are higher in the construct will see it, and so for example, walking several blocks is going to be more demanding than walking a single block. So we can, if we sort of think about the construct on the x-axis here, and then on the graph on the right, the probability of success, what shifting the difficulty is doing is moving the curve over. So that dashed curve is more difficult. So the probability of success for a person who's like a half a standard deviation up is substantially lower than it is on that solid curve. The graph on the right is showing the information. And one of the things that's sort of interesting about this particular thing is that the peak of that information function is right around where that difficulty falls on the construct, right? So right around the point where about half the people can do the task and half the people can't do the task, that's where you're getting the most information. The second kind of thing that we have here is discrimination. So discrimination are sort of things that either add reasons why everybody would get it right, regardless of whether or not the claim holds, where they are in the construct, and things that cause everybody to get it wrong. So, for example, negatively worded items with the word "not" in it. If the person just misses the word "not," they're going to get the question wrong, even though it's or use of unfamiliar language in a questionnaire, or if there's loud construction noises going on today, or the AC. Right? Those are all kinds of construct irrelevant variants. And what that does is that's going to change the slope of that function, and it's going to sort of spread out that information curve. The third kind of thing that we have to think about is changes which will change the mix of constructs that we're looking at. So if we take a math problem and change the numbers into algebraic expressions, we've already gone from the domain of arithmetic now to the domain of algebra. So we might be looking at a different context, right? So if I ask the patient to make an extension motion versus a rotation, that's changing which muscles and nerves and so forth are involved in that particular thing. So, to leave some time for questions here, I'll go kind of quickly through this, right? Deductive reasoning, this is sort of causal sort of thoughts that we have, right? So if you have our causal model, it's not necessarily true, but it's our model, is that if you have more of this construct, then certain claims will likely be true, certain evidence we're likely to see. And we're going to sort of turn that around using abduction to reason from our evidence to our hypothesis. So when we make the observation that's more likely when the claim is holds, that's going to increase our support for the claim. It's not going to go all the way. So a big question that we still have remaining here is how much evidence do we have to gather before we can really make the claim, and that's going to depend on the stakes of the decision, right? So it's going to be very different when the physical therapist is deciding whether or not to assign me this exercise or that exercise, because you can always change it next week. Whereas if the surgeon is deciding to do surgery, that's, they want a lot more evidence that the surgery is going to be helpful. The last thing we need to do is we need to make sure that the set of contexts we want to make claims about is matching the set of contexts that I'm measuring. So there's some reason to believe that, right? So people talk about black swan events. Black swans are very rare in North America and Europe. I saw one in Australia. I saw one in Singapore, right? So the reason I wasn't seeing any black swans is I wasn't looking in the right places. So one of the things that we have to be very careful about when we're thinking about the collection of observations that we're making is, are we really spanning enough of those different contexts that we want to make claims about that we can be confident in making those claims. So when we're planning an assessment, well, there's two different things we have to do. Is we have to make sure that we have a sufficient depth of evidence to support our claims, right? Enough repetitions of this thing, right? We just don't want to see them shoot the basketball into the hoop once, but we want to see them do it several times. And a sufficient breadth of evidence, right? So we want to see them perform the action in a number of different things. So we need to make some way of sampling from all the topics. So I'm going to finish up with two different things. This first one here is a right map, and this is the physical functioning scale. And Mark Wilson has a data set which he had distributed with his construct map program here. The blue bars up at the top are a histogram of the abilities of the subjects in this particular pool. And the white dots with 1 or 2 are the people who answered 1 or 2. This is a trichotomous scale. And so you can sort of see where the various things fall down on it. And so you can see, for example, this bathing item is way down towards the low end of the scale, and there's very few people that that's helping us distinguish between. So that's telling us something about the internal consistency. This is another version of that map. I did this one using some normal transformations instead of using the IRT scaling. That's why I call it the right map. The right map is named after Benjamin Wright. The wrong map is named for the fact that this is the wrong way to do it, and if I had enough data, I'd do it. I'd make a right map. But the thing I like about this one is it works with a pretty small sample size, so I don't have to worry about that. So those are both observation maps, right? Those are both telling about what we want, what we can see. And what we'd like to do is we'd also like to be able to make a similar map for the claims. And that might require an external study. So we might need to do a long-term follow-up where we follow what happens to the subjects a year or 2 down the line. Or maybe we want to get a subtest of the subjects and do one of those more expensive tasks that we couldn't do before. And so eventually what we want to do is try and put them both on the same scale. So, right, and so now we can kind of get to this idea of linking the internal and external scales, right? So so we might have a pilot study in which we can do the internal consistency kind of things, but a validity study where we try and get information about both the scores on whatever measure we've designed and the claims that we want to make, and look at whether or not we're really justified in that kind of thing. Sometimes for a research assessment, right, we might not need a lot of things because the purpose there is to try and understand the construct better. And if the measure falls apart, then we know that our theory of the construct isn't any good. Formative assessments are lower stakes because generally they're thinking about the day-to-day sort of thing, right? The physical therapist can change what exercise she's giving me if the one she had didn't work. The teacher can change their lesson plan if the lesson plan they picked didn't work. Summative assessments are often higher stakes, and now we need longer sorts of things, especially if we're going to say, oh, your admission to this particular university depends on you scoring this high in this test. So, right, I think I've said this a couple of times here. So I'll leave it at that. My slides are up there. Some of my other information is there. And I hope I've left a few minutes for questions.
Okay, Russell, thank you for that detailed look into all these measurement options. While we're thinking about questions, I guess I'll start out by asking, I felt throughout your talk I was kind of revisiting a lot of ideas that I've been exposed to maybe peripherally at times or more formally at other times. And I wonder if you have any thoughts about within experiments or within, I mean, you brought up physical rehabilitation a number of times, but certainly in educational testing, what are some of the common problems that we fail to appreciate? So within the number of constructs you mentioned, where do people kind of fall down on the job when they create a measure? You know, are there any sort of failings that you observe often that either researchers or maybe people in education testing commonly experience because they sort of overlook some of these important ideas?
So there's there's a couple of different things there, and one is, yeah, I'm tying together a lot of, trying to tie together a lot of older sorts of things. But one failing that we might have is tasks that are not providing good evidence for what we might want to do. So for example, if you look at the next generation science standards, right, there's 3 dimensions to that. There's the big ideas, there's the science and engineering practices, and then there's the domain knowledge. And it's fairly straightforward to test domain knowledge, right? You can have to put a picture of the neuron up and have them label all the parts of the neuron, right? That's pretty straightforward. Trying to now embed the science and engineering practices in there is much more complex. And so I think there's often a tendency to measure what is easy to measure rather than what is important to measure. If we don't think through this and say, oh, what I really care is whether or not they've learned the parts of the neuron. They can always look that up in Wikipedia. What I want to care is that they understand how the how neuron-to-neuron interactions work. Right? And so trying to get some clarity on that gets us out of the trap of just measuring what's there, what's easy to measure, right, rather than what we really want to know.
I'm going to be brave enough to try to ask a question that doesn't make me look stupid. It's a 2-part question. One is personal, because you clearly think on a different plane than many people. So I'm curious as to whether your primary education was more classic or industrial, because it seems to me you were taught to think how to think, not to think what to think, and to think how to know versus what to know. So that's my first part of the question. The second part of the question is, could you give some advice if there's a long longitudinal study with thousands of subjects and millions of data points, but it's largely a correlation study, where can you start making it causal, and what other parameters would you start looking for to make those claims?
So, boy, I don't know to what extent. I mean, I think I've always been sort of philosophical by nature, that I do that sort of thing. But I've had lots of industrial or near industrial experience. So, I did an internship at Honeywell, and it went through many of the engineering departments there, so I could sort of see what they were doing. And I was at ETS for 14 years, and I was in the research area, so I wasn't working on the day-to-day operations of the test, but that was right next door to me, and I always knew that I needed to make a connection between what people are doing and what I'm thinking about, how I'm describing it. So if my description of how to think about writing a test item helps the test developers who have to make, 5,000 new praxis items do their job better, then I've won there. As far as the longitudinal things, I mean, one of the things that there's a lot of people who have been interested in causal models. Yuta Pearl, Peter Spertes, Clark Weimar, a bunch of people in the sort of the AI space, and I've looked at it. But with me, it's sort of tendency to cause is sufficient for most of what I'm doing, right? If I have a theory of causality, I can sort of see, hey, is this model consistent with this theory or not? Or, are the data consistent with the theory or not? One of the things that's kind of interesting here, I've been thinking about the longitudinal models, is I've got this construct model, which is some collection of constructs that I'm measuring, and I'm assuming that they're going through time in some sort of process. So, if it's education, that might be a growth process. If I'm looking at something like depression, then it might be something that's steady state or cyclical or something like that. So they're moving with that process, and then we have exactly at each measurement time point, we've got the measurement model part, right? The link between those latent constructs we have and the observables. And that makes it a pretty tractable mathematical model. So there's a lot of tools out there. It's basically a hierarchical Markov model, and there's a lot of tools that are out there that work with those kinds of things.
I think we're out of time. Thank you for the presentation. It was very interesting. I felt like I was filling out a SMART form. Haven't done that in a while. But what I was wondering is, since you talked about this initially as a personal issue with regard to a practitioner or a clinician, do you think that clinicians do this just, physical therapists, they have many of the same kinds of problems for their patients. Are they doing this in any kind of organized way just for themselves as they look at patients with the same kind of problems? Or is this just related to the research side?
So I don't think that because as I said, I recently completed a bout of physical therapy, so I think I might have even talked to my therapist at one point about this. So I don't think that she has such an organized model of what she's doing, but she is obviously doing some sort of things like that, right? She's got some sort of theory about what my injury is and what it might do, and asks me to do various things, which helps her either confirm or refute that theory. The same way, I've thought a lot more about what either a classroom teacher might do or an intelligent tutoring system, right? And so there the idea is that you want to be periodically measuring whether or not the past instruction has taken, and use that measurement to then guide what you're doing next, right? So, oh, maybe if the students aren't getting this, I better go back and review it before going on. Or if, hey, if everybody's got this, well, we can rush madly ahead, right? So I've been thinking a lot about how to embed this the formative assessment problem, right? How to embed this measurement in a system where we're alternating between measuring and then making prescriptions of what to do next.
Just before we wrap up, I did want to get one more question in. This relates to the amount of data that's starting to come into our lives. We're getting great many measures. And I wonder if you could leave us with one thought, a recommendation for our educational system, specifically on testing, given your background. What could we do differently and more effectively to test our students to understand their competence?
So there's a bunch of different things that are going through my mind here, but one of them is sort of the measurement fallacy idea, that, right? As soon as you start measuring something, you have the Florida State assessment, and the teachers, you're tying it to the teachers' salaries and to the students' promotion and everything like that. And now, because of all those things, right, there's this real pressure to do that particular thing, unlike if what you were doing is just using it as more of a monitoring system to say, hey, are things working or are they not working? And if they're not working, what changes can we make to improve things? And so the latter is actually a sort of a pure measurement problem. The former gets contaminated by people trying to avoid the penalties and not measuring for what they're doing. The second thing I think to be very wary of with the big data is to make sure that the sample of data you have matches the population of interest. right? So there's a big tendency, especially the AI people, to go out there and grab available data, right? So you're mining your customer database, and what you're trying to do is get people who are not customers to buy your products, right? No, you're measuring the wrong people. You need to be measuring the not customers, because that's the people you're interested in. And I think that I've seen a lot of that sort of thing. Oh, let's rush and figure out some model that we were making using general available data and not thinking about the hard statistics problem of, hey, does this particular convenience sample generalize to the population of interest or not?
All right, thank you so much for coming, and thank you, Dr. Almond, once again.